We're looking at section 2.4. We're still working with the chain rule. Today we're going to throw in something a little bit more to it though, because we're going to have to simplify these trig functions by using what's called the double angle formulas. All right, so we're still using the chain rule, but at the end we're going to end up with some problems where we have to use this double angle formula. So to find this simplified form, if we are given a sine u cosine u, all we have to do to simplify something like that is we take our coefficient, we divide it by 2, and then we have the sine of, and we double our angle. You should have seen this in pre-calc, but I'm sure it's been a while, so let's talk about it one more time. When you're given this kind of form, a constant sine u cosine u, to simplify, you divide the coefficient by 2 and you double the angle. Let me show you how that actually works in the real world. Like, let's say that we end up with the problem and we have to calculate this. The 4 times the sine of 30 degrees times the cosine of 30 degrees. We have to evaluate something like that. This is in a sine u cosine u form. So to do this problem, I'd have to say it's going to be 4 times the sine of 30 is 1/2. The cosine of 30 is radical 3 over 2. 4 times 1/2, that's 2 times this. The 2's would cancel. This is radical 3. That's what I get for my answer. But according to this formula, I could have just done this. If I take the 4 and divide it by 2, I get 2. And then it should turn into sine, and I just double the angle. So what do I get if I double the angle? So these two should be equivalent. So if I do this now, this is going to be 2 times, what's the sine of 60? Radical 3 over 2. These cancel. And see how I still get radical 3? So this is a much easier computation than that is. And so that's why we want to have an easier way to write it. All right. Some other common double angle formulas are these. If I have a times cosine squared u minus sine squared u, or if I have either one of these two. But this is the one that's going to come up the most often, so I'm going to underline this one. If I have a cosine squared u minus sine squared u, that's just going to be a times the cosine of double the angle. So on these first problems, all we're doing is simplifying them. We're not taking derivatives. We just want to simplify by using the double angle formula. So if I look at my coefficient, it's 6. I have to divide it by 2. And then we have to double the angle. See how that works? On this one, we look at the pattern. It's a sine u cosine u. I have to take the coefficient. I have to divide it by 2. We have to double the angle. And it simplifies down to that. On this one, look at the pattern. Cosine squared u minus sine squared u. Cosine squared u minus sine squared u. On this one, do I have to change my coefficient at all? No, so the coefficient's going to remain a 1. So this is just going to go 1. I don't have to write that. Cosine of what? 4x. Right, because we have to double the angle. So that's just going to happen either at the beginning or at the end of our derivative problems. Okay, so now we're going to do some derivatives. So we've got f of x equals sine of pi x squared. Now, we have to determine what is our u. U is going to be whatever the angle is. Sometimes they put it in parentheses for us, and sometimes they don't. This is really in parentheses. Go ahead and put it in parentheses. So my problem starts off as sine u. What's the derivative of sine u? Look at your green sheet if you don't know. Cosine u. So this is going to be cosine u, but then we have to do times the derivative of u. So what's the derivative of pi x squared? Anybody know? We have to do the derivative of u, pi x squared, kx squared. Good job, 2 pi x. Do I multiply the 2 pi x times the angle, or does it become the coefficient? Coefficient. So I'm going to have 2 pi x cosine of pi x squared. That would be our derivative. We didn't have to use that double angle formula there. Look at example 1 compared to example 2. They look very similar. But number 1, we had to put the parentheses in ourselves. On number 2, they have the parentheses. But what's happening is not just the x is getting squared, but the pi x is getting squared. So I actually need to think of this problem as sine of pi squared x squared. See how the pi and the x are both getting squared? So this is what our problem turns into. So now think about it. Here's our parentheses. That's our u. So again, I'm thinking of it as sine u. Madison, what's the derivative of sine u? Cosine u. So we're going to have the derivative of sine u is cosine u. But now we have to do times the derivative of this u. How are we going to find the derivative of this? What kind of value is pi squared? It's a coefficient, isn't it? So this is really just kx squared. This is just a coefficient. If I were finding this derivative, I would do k times 2. So what are we going to do here? Right, pi squared times 2. So what's that going to give us? 2 pi squared, and then I would have x, and then what power is it going to be to? Just the first, because I have to subtract 1. This is our simple power rule. If I'm given kx squared, the derivative is k times n, x to the n minus 1. Here's what we get. We don't change this angle unless we use a double angle formula. So this just comes out in front. And that's going to be our derivative. Any questions? All three of these problems look very similar. Look at them. They all have sine, they have pi, they have x. Sine, pi, x. Look at how different these first two answers were. Look at the third one now. It still has a sine, a pi, and an x. But now the squared is here. Does anyone know what it means when the squared is there? It means that the whole value is getting squared. Not just the pi, not just the x, but the whole thing. So this actually means this. It's the sine of pi x. And then this whole thing is getting squared. Because if I were plugging in a value for x, I would have to multiply it by pi, take the sine, and then square it. Do you see how that's how I would evaluate it? Like let's say x is 2. I would plug in 2 for x, I'd get 2 pi. The sine of 2 pi is 0, and then I'd have to square that and I'd still get 0. So now I have to take the derivative. So how I'm first going to think of this is, as here's my outer parentheses. Remember, we're working our way inside. Up to now with the chain rule, we've only had to do it twice. Now it's going to get more complicated. We've got, this is our u. So what's the derivative of u squared? What is it, everybody? 2u, right? So I'm going to get, my derivative is going to be 2, don't change that u. Everybody see that? This is u squared. So the derivative is 2u. We have to work our way inside. I just did this. I took the derivative of u squared. It's just like you're unwrapping a gift. So we did the bow. We've taken that outer part off. Now we're to this part. We have to think, what's the derivative of sine of something? Cosine of that something, right? So this is going to be cosine of pi x. What did we just take the derivative of? Sine, right? Didn't we just take the derivative of sine? So now I just took this derivative, so I'm done with this part now. Working our way inside. What's the derivative of pi x? Pi, right? So now I've done this derivative. So can you see how now I'm finished? You can do that on every problem, guys. Get rid of the things that you've taken the derivative of, because you're working your way inside. So this is what we have then, and we're going to take this pi, it's a coefficient with the 2. But this would never be the answer that you would see as if it had been multiple choice, because more can be done with it. Does anybody know what else we could do with it? Double angle, good. Casey, go with that. What would it be? You're very close. What do we do to the What do you do to the coefficient? So what's half of 2 pi? So it'd be pi sine, and then what do we do to the angle? Double it. And that would be the answer that you would see. Sarah, what?
I don't understand that. I get everything else until you started doing the double angle.
Okay, so back to the double angle formula. The double angle formula says whenever I have something in this form, where it's going a sine u cosine u, that is equivalent to the coefficient divided by 2 times the sine of double the angle. That's what the double angle formula says. I showed it with this. I was trying to compute 4 sine 30 cosine 30. I said this is 4, this is 1/2, this is radical 3 over 2. I had to multiply all this out and I got radical 3. But then we said, what if we just use the formula? Divide this by 2, make it just the sine, and then double the angle. And we got the same answer. And you always would. So that's why in calculus, we want to have the most simplified answer, because later on we're going to have to plug in values for x. If I were to make you plug a value of x into this, it's pretty difficult to do. But if I made you plug a value of x into this one, it's not so difficult. So that's why we're simplifying it. Example 4. If we can simplify at the beginning, we should. Because if I just start this problem the way it is, I'm going to have to use the product rule and the chain rule. Yes, David? Well, I just showed an example of how it works. It works because these are called co-functions, and they actually end up having very similar values if you think of the 30, 60, 90s and 45, 45, 90s. That's why it ends up working. I'll explain it more after we get through this. But okay, so what about this one, guys? Can we simplify this at the beginning to avoid having to use the product rule? How can I just rewrite this original problem? Not take the derivative, just rewrite it. What could we do, Greg? Close, not quite sine of 6x though. There you go, 1/2, because remember we have to divide the coefficient. So we're going to do 1/2 sine of 6x. Now, a lot of people are like, oh, okay, I did something good, so now I'm finished. Unfortunately not. You did something that's a good thing to do, but we're not finished because we haven't taken the derivative. We've just given another name for this original problem. Okay, so now we're going to take the derivative. What do I do if I have a coefficient and I'm taking a derivative? Just bring it down, right? Look at your derivative formulas, guys, for all these trig functions. Oops, wrong side. If I'm trying to take the derivative of k sine u, it's k cosine u. I just bring down that coefficient. So I'm going to bring down the coefficient. I'm done with that. What's the derivative of sine of something? Cosine of the something. I just took the derivative of sine. I'm done with that. I'm working my way inside the parentheses. So what's the derivative of 6x? 6. I did this. Can you see how now I know I'm finished? I worked my way all the way inside. So now half of 6 is 3. Cosine of 6x. That's going to be our final derivative. And it's completely simplified. Nothing else we can do. All right, guys, just a couple more here. Let's look at this one. We have 3 tangent squared of pi x plus 4. I have to think, what would happen if I plugged in an x? Well, I'd have to multiply it by pi, add 4, then take the tangent, then square it, then multiply it by 3. See, I have to rewrite this problem. This would be rewritten as 3 parentheses tangent of pi x plus 4 squared. Do you understand how this would be the same thing? When I have that squared right there, it means that all of this stuff is getting squared. Not just the angle, but the tangent of the angle is getting squared. What is the first way I have to think of this? Am I going to take the derivative of tangent? Am I going to take the derivative of pi x plus 4? Am I going to take the derivative of 3u squared? Which one? 3u squared. That's my outermost part. So I'm taking the derivative of 3u squared. Right here, my outer parentheses, that's my u. So what is the derivative of 3u squared? 6u. So I'm going to have my derivative's going to be 6u, don't change the u. Okay, so now I've taken care of the 3 and the 2. That's done. So now I've done this part. Now I'm to this part. How do we do this derivative? If I have tangent of u, see now I have a new u. Whatever's in parentheses, the outermost parentheses, that's u. So what's the derivative of tangent u? Look at your sheet. Derivative of tangent u, secant squared. So I'm now going to have secant squared of that u. So we just now took the derivative of tangent, so that's gone. Working our way inside. What's the derivative of pi x plus 4? Pi, right? So now I'm going to have a pi. And now I'm finished. I've worked my way all the way inside of there. I've done everything that can be done. So now I'm just going to simplify. What questions do you have about that? All right. Last one here. So I'm going to rewrite this problem in a better way. Radical x, I should write as x to the 1/2. This is 1/2 Now, if I can get rid of something squared, I want to. Is this the sine of 3x that's getting squared, or just the 3x that's getting squared? Just the 3x. So I'm going to go ahead and square it, because I'd like to get rid of the fact that I'm going to have to use the chain rule twice there. If I just get rid of those parentheses by squaring it out, now I can think of the problem like this, and it's easier to do. So if you can square something, go ahead and do it. So now we have the derivative of x to the 1/2. This is 1/2 x to the negative 1/2. And now we have to do the derivative of sine. Here's my parentheses, that's my u. This is the derivative of k sine u. That's going to be k, what's the derivative of sine u? Cosine u. So I took care of this derivative, I did this derivative, but I haven't done this part, working my way inside. I did the derivative of sine, but not the derivative of this. And what's the derivative of that? No, you got to do k times n, 18x. So now I did this derivative. So now I'm finished. I'm going to go back and rewrite this. I have x to the negative 1/2. That's going to be 1 over 2 radical x. This gets multiplied by out in the front, so half of 18x. That's going to give us 9x. Cosine of this. Why do you think I wrote this as 3x quantity squared instead of 9x squared? Exactly. In the original problem, it's given as 3x squared. I would like to keep that consistency. Okay? Guys, this is difficult stuff, but you can do it. You just have to practice it. And once you do it a few times, then you're like, oh, okay, it makes sense. But the whole thing to this is, if you have a quantity squared, you have to write that out. Like right here, where we had this sine pi x squared, we had to write that out. Sine pi x squared. And we think of it as u squared, 2u. We keep working our way inside. Okay? All right.